I think we had one more left on that one page, and I'm going to write it in. Did we do the one with nitrogen together? We did that one together. Oh, so we did all three on that page? Oh, okay. Oh, never mind. All right, so let me regroup. All right, so now we're going to look at some conversions with Avogadro's number, and then we'll look at some conversions that use both Avogadro's number and molar mass. So when we're using Avogadro's number as a conversion factor, the hint that we're going to be using that is we're going to see some kind of particle mentioned in the word problem. So I've defined those before. It could be atoms, it could be molecules, it could be formula units, or it could be ions. So those are all different types of particles depending on what type of compound it is. And when we use Avogadro's as a conversion factor, is 6.02 times 10 to the 23rd particles per 1 mole. Oops, I'm supposed to say mole. So in other words, the 6.02 part of it always stays with whatever the particle is. And then 1 always goes with the mole, just like 1 always went with the mole if we were using molar mass. So those are going to be some of our things that we're going to be looking at, and then we'll look at using both of them. All right, so let's just get started on this one. It says how many atoms of lead are in 3.80 moles of lead. So that is my given. And I want to get to atoms of lead. So this is a mole to atom, which is 2 steps or 2 boxes. And whether it's mole to atom or atom to mole, those are both going to be 2 boxes. I see atoms in there. That's the type of particle. So that gives me the hint that I'm going to use Avogadro's number. I don't see anything about graphs. I don't see anything about grams or mass. So I'm not going to be using molar mass. And then I want my answer because of my given. I want it to have 3 sig figs. Molar mass and Avogadro's number, those are conversion factors. Those don't come and take into account for the sig figs. So we're going to go ahead and get started just like we did before. And we'll start with our given, which is 3.80 moles of lead. And we'll end top closest to our equals with what we want to convert to, which are atoms of lead. So I give myself a beginning and I give myself an end. And then I thought now I start following my units. If I'm moles of lead here, I have to be the same thing down here. So this is going to be moles of lead because I need that to cancel out. So up here is where I get my hint that I need Avogadro's number because atoms is a type of particle. So 6.02 times 10 to the 23rd is going to go up there. And opposite of it is always 1 mole. Whatever type of particles, you always have 1 mole. My units cancel and I'm left with just atoms of lead, which is what I wanted. So now at this point, you're just going to take 3.80 and multiply it by Avogadro's number. So I want you to try that in your calculator. Since you're multiplying by 10 to the 23rd, your number should be getting very big. So be sure that you look at the end. You'll see E. That's your exponent. That's the number that should go with as your exponent. Leah, what'd you get for that? Now remember, we want only 3 sig figs, so that would become 2.2 what? And then did you get an exponent at E? Okay, so times 10 to the 24. And my units are always right there left, atoms. So that's going to be conversion where you're just using Avogadro's number. We're going to look at different kinds. One of them you multiply by Avogadro's number. The other one you're going to divide by it. When you divide by Avogadro's number, you have to put it in parentheses, because if not, the calculator does like the wrong order or something, and you end up getting a really large number instead. No, ma'am, because it's across. So we multiply across and then divide by what's on the bottom. In this case, it was just a 1. So you should have done 3.80 times 6.02 times 10 to the 23rd. Did you get it? All right. All right, we'll look at another one that's just using Avogadro's number. It's just a reverse of that one. So on this one, I have 8.24 times 10 to the 24 atoms, and I want to convert that to moles. So this is an atom to mole problem. So that still is 2 steps. So that's my first thing I'm going to do. Give myself 2 steps. I see a type of particle. I see atoms. So that tells me I need to use Avogadro's number. And then when I get my answer, I want 3 sig figs, because only the coefficient portion of a scientific number counts. So I need 3 sig figs for my answer. So those are kind of just things I dissect. And then once I do that, I give myself a beginning. So there's my given, 8.24 times 10 to the 24 atoms. And I give myself an ending. So that is moles of sodium. I'm starting in atoms of sodiums, and I want to convert that to moles of sodium. And then I follow my units. If I'm atoms up here, I have to be atoms down and diagonal, so they will cancel. So atoms is a type of particle. So now I'm going to use Avogadro's number. Is the 6.02 part going to go at the top or at the bottom? Bottom, because it stays with the particle. So 6.02 times 10 to the 23rd atoms is always per 1 mole. Whether you use molar mass or Avogadro's number, opposite of that is always per 1 mole. So my units cancel. So I'm going to multiply across, which it's just times 1, so I won't change it. When you have Avogadro's number on the bottom, you need to put it in parentheses. So if you'll give this one a try, please. Putting it in your calculator. So should my number be getting larger or smaller? A lot smaller, right? Because I'm taking 10 to the 24 and divide it by 10 to the 23rd. And we want 3 sig figs, we said. Kelly, what did you get on that one? I'm sorry. I got 13.7 moles. Did you put Avogadro's number in parentheses? Okay. Yeah, take that number and then divide it by Avogadro's number in parentheses and see if you can't get that. If you got a real large number like 10 to the 40 something, then it's probably because you forgot to put this in parentheses. Good. All right. All right. So now we're going to look at some that we use both Avogadro's number and molar mass. So those end up being 3 steps. So I want to make that into a 3-step. I call each box a step. So if I read this one, it says how many atoms of potassium are in 3.99 grams of potassium. So here's my given. And here is my unknown. So it's a gram to atom problem. So I see atoms in there, so that tells me I'm going to have to use Avogadro's number as a conversion factor, but I also see grams or mass, so that also tells me I'm going to have to use molar mass. So that's why you're going to have to use 2. And then 3 sig figs again. It seems like a lot of these are 3 sig figs. So I need 3 boxes because I'm using 2 conversion factors. All right, I'm going to start with my given, 3.99 grams of potassium. And I want to convert to atoms of potassium down here. Always want my unknown to be at the top closest to my equals because that's my last unit I'll be left with. And then we just start following our units. If I'm grams of potassium here, I have to be the same thing down here. So they will cancel. So when you see grams within the problem, what does that tell you you're going to have to use? A molar mass, yes ma'am. And since it's potassium, at least it would be nice and easy. So you get it straight off your periodic table. It's element number 19. So we would do 39.10. And that's always opposite per 1 mole. And then I keep on following my units, moles of potassium. So I have to be moles of potassium down here. But there's my hint that I need atoms. So where's Avogadro's number going to go? Top or bottom? Remember, it always stays with the particle. So it would go up here with the atom. So 6.02 times 10 to the 23rd atoms per 1 mole. Notice within the problem, so not the given, but within the problem, if I have mole anytime, it's always just 1 mole. So my units cancel, moles of potassium, I'm left with just atoms. So now you're going to multiply across. So 3.99 times Avogadro's number, get yourself an answer. So if you'll try putting it in your calculator. And once you multiply across, then come back and divide by what's on the bottom, the 39.10. So now is my number going to get smaller or larger from the original 3.99? A lot larger, right? Yeah. So be sure you don't miss your exponent. Treasure, what'd you get? 10 to the 22. atoms. Sorry, that got kind of squished. It's supposed to be 6.14 times 10 to the 22. If for some reason you're not getting those numbers, but you have it set up right, then when we stop practice and let me help you out, because I mean, if you do all this work and get it set up right, I would be upset myself if it was just a calculator issue. All right, so we'll look at one more and then y'all can try one. So it's still going to involve this type of conversion. It's just going to kind of be flipped. All right. So now we have how many grams of helium are in 3.03 times 10 to the 23rd atom. So that's my given. My unknown, I want to get to grams of helium. So this is an atoms, any kind of particle, in this case, atoms to grams, and that is 3 steps. If it's 3 steps, it's because I have to use both molar mass and Avogadro's number. So atoms is a type of particle, so that's my hint. I have to use Avogadro's number. And then grams or mass was a hint that I have to use molar mass. So that's my 2 conversions. That's why it's an extra step. And then once again, I feel like all of these almost all have 3 sig figs. All right, so I kind of dissected everything. So now I'm going to get started with my given 3.03 times 10 to the 21 atoms. And I want to convert to grams of helium. All right, now I've done the beginning and end, so I'm going to follow my units. If I'm atoms of helium here, I have to be atoms of helium down and diagonal, so they'll cancel. They'll cancel. I'm having trouble. If I see atoms, that's a hint that I need to use what? What number? Avogadro's 6.02 times 10 to the 23rd atoms. That's always per 1 mole. And then I keep on, I got moles of helium here, so I have to have moles of helium down here. Above that, I have grams of helium, so that's my hint. I need a molar mass, once again, just an element, so I can get it straight off the periodic table. Helium is element number 2. So 4.00 grams per 1 mole. My units cancel. I'm left with just grams of helium, which is what I wanted. So now I just need to put it in the calculator. Since Avogadro's number is on the bottom, you're going to need to put in parentheses when you divide. So you're going to multiply this times this and get an answer and then come back and divide by Avogadro's number. So my number should be getting smaller. 10 to the 21 is a very big number, but I'm dividing it by 10 to the 23. What'd you get, Mark?
0.020.
0.02. So we want 3 sig figs. Remember, that doesn't count as a sig fig. So it should be 0.020 and then a 1. So you'll get your 3rd sig fig, okay? And that's grams. This is considered a placeholder or a leading, so these are my 3 sig figs. Did anybody not get that? If you got a huge number, then once again, maybe try it with putting Avogadro's number in parentheses. All right. Excuse me, I'm sorry, ma'am. $200 million. Okay, let me come and look at it more in a minute, okay? Try that. I want everybody to try that next one and see if you can do that. It's going to be a 3-step. But that's why it's a good thing to try some of the practice problems, because then if you make a little calculator error, you find it out before the test or quiz. All right, so that's still going to be 3 steps. So you're going to have to use Avogadro's number, and you're going to have to use molar mass of just lithium, which is a group 1 metal. So it's really easy to find. So our given is grams of lithium, and then we want to get to atoms of lithium. So once again, you see both of those hints that you're going to have to use a molar mass. Jerry, don't have your head down, do you, sir? Okay. Felt like you did. So I'm gonna follow my units. If I'm grams of lithium here, I got to be grams of lithium down there. So what am I going to use right there? It says grams. The molar mass, right? So what's our molar mass for lithium? Perfect, grams per 1 mole. Then I follow my units. If I'm moles of lithium here, I got to be moles of lithium down there. So cancel, but I see my hint atoms up above. So that's where my Avogadro's number going to go. 0.2 times 10 to the 23rd atoms per 1 mole. And now I just make sure I've set everything up right, and I did. I'm left with just atoms of lithium. So I'm going to take 0.755 times Avogadro's number, give me an answer, and then come back and divide it by 6.94. And I got 6.55 times 10 to the 22nd atoms. Anybody else get that one? That number? Yes. All right. All right. So that's what you're doing on your practice. If you look at your practice on the front side, off to the little side, like you'll see my messy handwriting, it's telling you what kind of problem it is. And then it'll either have a 2 or 3 that's telling you how many steps to kind of help you out on the first side. And then on the back side, then it doesn't tell you those 2 things, because then you got to start figuring them out for yourself, because that's how it'll be on the quiz or on the test. So you got to get started. You got to give it a try. At least get yourself started by knowing how many boxes you need, and then give yourself your given and what you're trying to find, and go from there. If you're having trouble getting it out of your calculator, if you think that's what the problem is, then let me know, and I'm going to come and help you look at that. So, and our quiz over this will be on Friday.